Dear student of class 12, today I'm going to start the method of substitution. I'll continue with the method of substitutions. Now, today we'll discuss the substitutions of substitution of trigonometric functions. Now, for this kind of question, integration dx over x square under root 1 minus x square. For this only, we'll substitute the trigonometric function over here. We have already discussed these things. The which quantity that you have to substitute, we have already discussed in inverse trigonometric function as well as in derivative. If it is 1 minus x square, that you have to consider x equals to sine theta or cos theta. You can take a reference of those videos for the substitution. Now I'll continue. If it is 1 minus x square, either you have to substitute x equals to sine theta or cos theta. For this only, I'll consider let x is equals to sine theta. Now then differentiate this function, derivative of x is dx. Will write the derivative sine theta is cos theta d theta. Now then the value of dx is cos theta d theta by the value of x is sine square theta under root 1 minus sine square theta. Now integration cos theta d theta over sine square theta. Under root 1 minus sine square theta is cos square theta. Root and square get cancelled. Now it is integration of cos theta d theta over sine square theta into under root cos theta. Cos theta get cancelled. Now we have 1 over sine square theta. 1 by sine is cosec square theta d theta. Now the integration of cosec square theta is minus cot theta plus sec. Your answer should be in terms of x. So now we have x equals to sine theta. So you have to convert this cot in terms of sine and cos. Cot means cos theta over sine theta. Or you can use Pythagoras theorem also, like inverse trigonometric function. Now then cos theta, I'll write under root. Cos theta means under root 1 minus sine square theta over sine theta plus sec. Therefore, substitute the value of sine theta. Sine theta is x minus under root 1 minus x square over x plus sec. This one is the required answer. Now it is x square minus a square. For this only, I'll consider let x equals to, if it is x square minus a square means x equals to either sec or cosec. I'll consider let x equals to a sec theta. X equals to a sec theta. Then differentiate this is dx is equals to a derivative sec theta is sec theta tan theta d theta. Now then substitute. Integration dx is a sec theta tan theta d theta over the value of x is a sec theta on the root. It is a square sec square theta minus a square. Sec theta get cancelled, a get cancelled. Now it is integration of tan theta d theta over. Now within a root, a square is common. If you take a square common from the root, outside the root it will be a. Root and square get cancelled, and what remains inside the root? It is sec square theta minus 1. Now then I'll write a is a constant. Outside the integral I'll write constant quantity. Integration tan theta d theta by sec square theta minus 1 is under root tan square theta. 1 by a integration tan theta d theta by under tan square theta is tan theta. Cancel. It is 1 by a d theta. Now the integration of d theta or integration of dx is x. Similarly, the integration of d theta is theta plus c. Now then the answer should be in terms of x. Now say we have over here, you have to calculate the value of theta from this. X equals to a sec theta. How to calculate? Now say x equals to a sec theta. Then sec theta is equals to x by a. Then theta is equals to sec inverse x by a. Now substitute the value of theta. Therefore 1 by a sec inverse x by a plus c. Now first copy this question. Now take a screenshot. Now the same question I'll do by another method. Now dear student, now the same question we can do by any other method, like I did substitutions. Now next I'll use some trick over here. Now another method without trigonometry also I'll do this question. Now sir, what you have to do is you have to multiply both numerator and denominator by x. If I multiply both numerator and denominator by x, what will get? X dx over x square on the root x square minus 1 minus a square. Hope these things are clear. Multiplying both numerator and denominator by x square. Now then I'll substitute the root quantity equals to z. Let on the root x square minus a square is equals to z. To remove the root, squaring both sides that you have to do. If I square, the root will remove, it will be z square. Now then differentiate 2x dx. Derivative a square is 0. Then 2z dz. 2 to get cancelled. Now the x dx is equals to z dz. Now we have value of x dx over here. Integration x dx is z dz by. Then what is the value of x square? It is from this. It is z square minus z square plus a square. Then the root quantity is z. But over here that you have to use another chapter. I haven't done this chapter. Now the next chapter I'll use these things. Now the integration in this form, I'll use formula. This is a new formula. Dx over x square plus a square is equals to 1 by a tan inverse x by a plus c. So I'll use this formula. Now 1 by a tan inverse z by a plus c. Therefore 1 by a tan inverse 1 by a, and the value of z is on the root x square minus a square plus c. So the answer is totally different, but both the methods are valid. Integration you can solve by so many different methods. You'll get a different answer, but the full marks is awarded for the equivalent answer. The substitution quantity in dear student, the substitution quantity that you have to remember. You have to practice many times these questions, then only you'll remember the trick. Let x equals to, I'll consider a cos theta. X equals to a cos theta on the root a plus a cos theta over a minus a cos theta. Differentiate that you have to do. Dx is equals to a, derivative cos theta is minus a sin theta d theta into the derivative of the value of dx is minus a sin theta d theta. Now after this, a I'll take common from the numerator as well as from the denominator, so that a get cancelled. It will be 1 plus cos theta into 1 minus cos theta into minus a sin theta d theta. Now then I'll use formula submultiple angle. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2 minus a. Sin theta also I'll use formula 2 sin theta by 2 cos theta by 2 d theta. Now that 2 to get cancelled. Under root cos square theta by 2 is integration, it is cos theta by 2. Under root sin square theta by 2 is sin theta by 2 into minus a 2 sin theta by 2 cos theta by 2 d theta, so that sin theta get cancelled. Now then I'll write minus a outside the integral. Now what remain over here? 2 cos theta by 2. Cos theta by 2 is cos square theta by 2 d theta. Now it is minus a 2 cos square theta by 2 is 1 plus cos theta d theta. Now the integration. Integration of 1 d theta is theta. Integration of cos theta is sin theta plus a. But you have to convert the things in terms of x or a. Now then theta, we can easily calculate the value of theta from this. Now the value of cos is given, so I'll write minus a theta. Afterwards I'll substitute. First I'll convert the sign in terms of cos. Sin theta means under root 1 minus cos square theta plus c. Now first take a screenshot of this, then I'll continue. Now I'll rub these things. Now then from this relation, what will be the value of theta? Cos theta. Cos theta and theta. Now say using this, x equals to a cos theta, then cos theta is equals to x by a. Theta is equals to cos inverse x by a. Now this quantity that you have to substitute over here. Now then we'll have a, the value of theta is cos inverse x by a plus under root 1 minus cos theta. The value of cos theta will be x by a. If you substitute over here, it will be x square by a square plus c. Now then the simplifications that you have to do over here. Now I'll rub these things. Now then I'll open this bracket. It will be minus a cos inverse x by a minus a. Within a root I'll take a square. I'll assume it is a square minus x square by a square plus c minus a cos inverse x by a minus a on the root a square minus x square by on root a square is a plus c. These two quantities get cancelled. Now both the quantities are negative. You can leave your answer like negative only, or you can take common. If I take common, it will be x by a plus on the root a square minus x square plus c. Complete answer. Now dear student, another tricky questions. Now so for this kind of questions, what you have to do is, it's a trick that you have to remember, multiplying the denominator by 1 by root x and divide by 1 by root x. Now say what I'll do over here. I'll write outside the integral 1 by root 2 dx over sin x into 1 by root 2 plus cos x into 1 by root 2. Why I am choosing 1 by root 2 over here? In trigonometry table, there is a common value of sin 45 is 1 by root 2, cos 45 is 1 by root 2, common value of sin and cos. If you take 1 by root 2 common, 1 by root 2, 1 by root 2 get cancelled. Multiply by 1 by root 2 and divide by 1 by root 2. Now, in place of 1 by root 2, I'll write sin x, then it will be cos 45 degree, pi by 4. In place of 1 by root 2, we can write cos pi by 4. Cos 45 degree is 1 by root 2 plus cos x, and another 1 by root 2 is over here. This I'll replace it by sin pi by 4. Cos 45 degree is 1 by root 2, sin 45 degree is also 1 by root 2. Now after doing these things, now what you'll get, this denominator quantity is in terms of formula. Which formula? Sin A cos B plus cos A sin B. Compound angle class 11. Sin A cos B plus cos A sin B is sin A plus B. Formula. 1 over sin is cosec. 1 over sin is cosec. Cosec x plus pi by 4 dx. Now that the integrations that you have to do, now I'll consider the substitution. Let x plus pi by 4 equals to z. Dx is equals to derivative pi by 4 is 0, it will be dz. Now then it is 1 by root 2 cosec z dx is dz. Now the integration of cosec x, log of tan x by 2 plus c, x is z over here. Now then substitute the value of z. The value of z is x plus pi by 4 divided by 2 plus c. Now then divide 1 by 1, that you will get the perfect answer. Tan x by 2 plus pi by 8 plus c. This is your required answer. Now with this question only, I'll stop this chapter, method of substitutions. Now from next video, I'll do integration of some special function. Thank you.